Hi, this is Amason, Assistant Professor, SNS College of Technology. Now we are going to discuss about the continuity of the last topic in this unit. This is the process flow chart. So everybody, robot cycle time analysis used to design, analyzes the various flaws in the robots and also able to identify what are the important features and how it has been taken into considerations, right? So once they have done, we have to make a process flow chart. So the process flow chart is nothing but it is an visualized application of a robot program. So this is important in robot cycle time, robot working function. The process flow chart is to be done. How it has to be done has been to be explained clearly. So before we go into the topic clearly, I like to show the presentation on process flow chart. So everybody knows the process flow chart is like as in several technique. This technique appears to be a visual learners as it graphically learn the programming task. If the first student to think logically about the entire problem rather than jumping on relying on the guess and check. It creates a level of obsession to follow the students to attack the software design problem at a higher level without getting bogged down in the details. This will become a necessary as the problem complexity as grows into a higher level. So it reinforces the best practice of commenting inside the next three programs by giving the points of corresponding the flowchart flags. So it's set up for the success with increment or iterative process. You get if one get blocked working, then the work on the next step and combine those two into an working whole. The whole works on the next step. So this is how the flowchart process has been stated from users only start to end, and also decision blocks also can. By using this, the process flowchart is an industrial engineering. It is one of the graphical and symbolic representation of processing activity performed on the workpiece. So the example for that process flowchart, how we can able to use this, it is used when observing a physical process to record actions as they happen and thus get an accurate description of the process. Similarly, when we go for that using this analyze the steps into a process, it will help identify and eliminate the waste. It is used in the when the process is mostly sequential and containing a few decisions. And also that the process project makes a stage by stage layer. Once the start procedure has been done, there is will be an intermediate. There is a decision block. When the decision block yes or no, there goes an upper flow. Whether this thing has to be done or this thing has to be done. Then finally the action blocks are also there. So this is a graphical representation, as I said that earlier, it is a graphical representation, right? So this is an example of the symbols used in the process project. There is the important. I have listed five graphical representations of the process or symbols of the process project. The first is an semi-over. This is operation. It is the main step where the part of the material or product is usually modified or changed. Then the rectangular bar shows the inspection, which indicates a check for a quality or a quantity. Then the third one is transport. Arrow mark symbol. The arrow mark symbols on which way the transport has to be done. The movement of workers or materials or equipment has to move from one place to another place. Then finally, the down triangle mark represents the control storage in which the material is received into or issued from a store. Or an item is retained for reference purpose. This is how the symbols has been used. Finally, the delay component is the symbol, fifth symbol shows the delay or a temporary storage, which indicates a delay in the process or an object laid aside until it is required. So this is some important process flowchart symbols. By indicating these symbols, I like to give an example of some process flow which has done place into considerations. The process flowchart, which I give a sample flowchart, how the process has to be done entirely. So as I said, there is a start-stop symbol, there is a end right. So power on is an function, scan environment, whether the function has to be done or not, then generating the map and location and the plan route. If the plan route is right, the route goes directly goes for a route. So the route is either right or not. That has to be done in a X symbol. Once the done has been done, otherwise it has to return back. So the route has to be clearly identify how it is. Follow the route. So the finish, if the route is finished, yes, the backup has been off. If no, the battery level has to be checked. If battery level is yes, then it goes for vacuum off. If battery level is low, it gives either to get a vacuum full. Once the vacuum full is yes, the vacuum is off in the left field conditions. If no, again it has to go for the follow rotor. Once that is a vacuum off in two conditions, when the vacuum is low and vacuum is full, so return to the power dock, otherwise stop moving. So once the return to power dock, the power has to be shut down, the error indicator has to be on, and if the vacuum has stopped moving has been stopped, finally it comes under the end conditions. This is the process flow chart has to be done for every process has to be done in a certain considerations. Um, this is the reference I have took for today's session and the video. Thank you for watching this video. We will catch up with the next sessions. Till then, bye-bye. Thank you. This is signing off, Sambasam, Assistant Professor, Residence College of Technology. Thanks for watching this video.